probably be helpful to rewrite this. The cube root of x would be x to what power? The cube root of y would be y to the 1/3 equals 12. So if we do this derivative, the 1/3 comes down, x, if you subtract 1 from the power, that's negative 2/3. And do the derivative of y to the 1/3. 1/3 comes down, y, subtract 1, times, what's the derivative of y? Equals the derivative of 12, it's just 0. Alright. Strongly recommend, if you're going to have to do a second derivative, clean the first one up as much as you can. What would you want to do now?
Divided by 1/3 divided by -2/3.
Okay. 1/3 x to the negative 2/3 divided by 1/3 y to the negative 2/3. Okay, those 1/3 can cancel and just leave us with a negative. Let's clean this up just a little bit more. If you have x to the negative 2/3, where would that go? And y to the negative 2/3 would come to the top. Okay, that just makes it a little bit nicer so I don't have all these negative exponents. There are other equivalent ways you could write this as well. You could have like negative y to the 2/3, x to the negative 2/3. That would work as well. But now if I want the second derivative, we have to work from here. So the way we have it written, we'd have to do quotient rule. So low, d high. So we have negative the 2/3 comes down. Y, subtract 1 from the power, so negative 1/3. Minus high. D low, derivative of the bottom. So the 2/3 comes down. X, subtract 1 from the power. Oh, what did I leave off? Right there. Okay. Over low square. Now we have a lot of cleaning up to do. We have negative 2/3. X to the 2/3. Y to the negative 1/3. dy dx is negative y to the 2/3 over x to the 2/3. Okay, second term minus an a would make plus 2/3. X to the negative 1/3, y to the 2/3. Over, this would be x to the 4/3. Okay, quite ugly. You really need to go slow on these problems so you're not missing something. There's a lot of pieces. But this is about to get a lot better. Because if you have x to the 2/3 and then an x to the 2/3 on the bottom, those can cancel. If I want to get rid of a fraction and a fraction, I could multiply by 3 on top and bottom. Let's see what this does for me. So then we would have a negative 2 times the negative y, so it becomes a positive 2. With my y's, I add exponents, so negative 1/3 plus 2/3 is 1/3. That's 2. So negative 1/3 y to the 2/3 over 3x to the 4/3. You guys okay with me there? There are other things you can do at this point. Like if you wanted to get rid of the x to the negative 1/3, you can multiply by x to the positive 1/3 on top and bottom. And that would be a nicer answer, but I will actually take either. So if you left it, I would accept this. I wouldn't count off. Or if you take everything times x to the 1/3, you get 2x to the 1/3, y to the 1/3, plus 2y to the 2/3. On the bottom, if I took it times x to the 1/3, that'd be 3x to the 5/3. So I would also accept that. So I'm looking for some simplification, but I am not asking you to go as far as possible on all these problems. So there are multiple correct answers here. It just has to be equivalent. All right. Any questions there? Let's take a look. The second part of this is dealing with our inverse trig functions. So if I asked you to find the derivative of this, remember in this situation with the trig function, that -1 doesn't mean 1 over sine, it's asking for the inverse. So an inverse is like the angle. So if I said sine inverse of 1/2, I'm asking what angle makes sine equal 1/2. So we have to rewrite this before we can do anything. If we think about this, we just thought about a triangle for a moment. Okay, what this says, sine inverse of x equals y is the same thing as saying sine of angle y is equal to x. So this is my angle. Sine is opposite over hypotenuse, so that would be x over 1. You could do Pythagorean theorem to find your missing side. So if we did that, we have x squared plus b squared equals 1 squared. So my missing side is the square root of 1 minus x squared. We have to have it written this way in order to calculate the derivative. So if we think about this, the derivative of sine is cosine. Inside stays the same. But you would have to multiply by dy dx equals the derivative of x, which is 1. So dy dx is 1 over the cosine of y. But if I want it in terms of x, we can use this triangle we have set up. What is the cosine of y? So y is the angle, cosine is adjacent over hypotenuse, so radical 1 minus x squared over 1. It's just radical 1 minus x squared. So this is the derivative of inverse sine. If you look at page 214 in your textbook, so you might want to grab your book, page 214. It has a table with all the derivatives of these inverse functions. I am not going to make you memorize these, and it would be very unlikely that I would put these on a test or a quiz. Okay, they don't come up a lot, but I will probably put, well, there will be a couple on your homework because you can reference this table to look them up. My theory is if you have a career where you're using these inverse trig functions, you'll memorize those 6 things, but otherwise we're really not going to use them much. So we just derived the sine one, so you'll notice that's the same thing as what we got. And I will go ahead and derive another one for you, and then I think your homework might have you do cosine. So just so you are aware. Let's prove another one. Let's do the derivative of tangent inverse. So what that means is tangent of angle y is equal to x. If I ask you to work this out, the derivative of tangent is times the derivative of the inside derivative of y would be dy dx equals the derivative of x, which is 1. So what dy dx is 1 over secant squared y. But if I want that in terms of x, we have to figure out what secant squared y is. So that's where the triangle comes into play. Tangent of y, so my angle is y, is x. Tangent is opposite over adjacent. So my opposite side is x, my adjacent is 1. So then we can do Pythagorean theorem. 1 squared plus x squared equals c squared. So my missing side is the square root of 1 plus x squared. Okay, so secant is hypotenuse over adjacent. We have secant squared. So if we square a square root, that cancels, and we can drop the over 1. So dy dx is 1 over 1 plus x squared. That is the derivative of tangent inverse. If you check that table, that's equivalent. So we just proved the derivatives for sine and tangent inverse. Does this make sense? Do you understand where that's coming from? So let's try a couple problems involving those. If I ask you to find each of these derivatives. A, I want the derivative of 1 over sine inverse of x. Okay, there's different options. 1 over means we have sine inverse to the negative 1 power. Okay, what is the derivative of the outside? So my outside, negative 1, comes down. Inside stays the same. Subtract 1 from the power, so it's now to the negative 2. Times derivative of the inside, derivative of sine inverse. That's what we proved right here. The derivative of sine inverse is 1 over the square root of 1 minus x squared. On your homework, you're welcome to just look at that table and pull those definitions. Do not have to memorize them. So that is 1 over square root of 1 minus x squared. So now if we just clean this up, we have a negative 1, sine inverse of x to the negative 2, so that would be on the bottom. That's sine inverse squared times the square root of 1 minus x squared. Not pretty at all. There are other ways you could have done it. You could have rewritten the 1 over sine inverse as cosecant inverse and worked from there. This gives us an equivalent. What questions do you guys have? Why don't you try B? Just try setting it up. Remember, arctan is the same thing as tangent inverse. So what you have is x times tangent inverse of the square root of x, or x to the 1/2. So you're going to have to do product rule and chain rule here. Our derivative, we have to do the product rule. So derivative of the first, derivative of x is 1 times the second, plus the first times the derivative of the second. What is the derivative of tangent inverse? Look at your table or the one we already proved that one.
1/+x.
X is just representing your angle. So since my angle isn't a plane x, I have to take my angle x to the 1/2 square. So a little bit confusing because the formula uses x and this has an x to the 1/2, but it's 1/1 plus your angle squared. Now, since my angle wasn't just x, we have to do the chain rule here. So times derivative of the inside. What is the derivative of x to the 1/2? So then if we clean that up, we have tangent inverse of x to the 1/2, or if you want to write it as the square root of x, that's fine. Plus, okay, I can take my x times my x to the -1/2, and so that would be x to the positive 1/2. And then on the bottom I have 2 times 1 plus x to the 1/2 squared, which is the x. Not pretty, but we got there. Would you guys like additional examples over anything that we've done? So, I know we have quite a bit of time today and you have all class tomorrow. Today you might try to focus on, like if you know you're really confused by these, you might want to try these first while I'm here. So that homework was given to you. Remember those circled ones would be the ones involving the inverse trig function. So like what we just did. If you want to do them out of order, that's fine. But you have time to work and ask me questions right now.